Okay, for today's session, we're going to continue with what we have left before. So last time we have looked through how we can calculate the no how do can we do the hypothesis testing for one sample test, whereby the situation is that we have non-variance or non-standard deviation given. In this case, the population standard deviation or the population variance is none. You already know, or given assume certain values, and also with a large sample size, right? So last time we have looked through that we're going to do that using the Z test. We can test the hypothesis using the Z distribution or the Z statistics. Okay. For this time, we're going to look at the continuation of what we have left before in this situation. In such a case that we have the sigma unknown, or the population standard deviation is unknown. So you don't know what is the population standard deviation. So that means in this situation, you have to estimate. Okay, you have to estimate the standard deviation from the sample. And of course, even though you can estimate the standard deviation from the sample, you still need to assume that there is an assumption that the data come from the normal distribution. Okay, that is a must. If it is not normally distributed, then you cannot use the parametric test. In this situation, you cannot use even the t-test, even though you have a small sample size or a large sample size. But in this situation, you have to use the t-test such that the sigma is unknown, and if the sample size is large enough, then you can use the Z test. The situation is when you have a small sample size. When we say small sample size, meaning to say that your sample size is less than 30. So in this situation, your N will be less than 30. Okay, such that the N is less than 30. So whenever you have N is less than 30, then you have to use the t-test. Suppose that you have N greater than 30. Okay, greater than or equal to 30, but you have unknown sigma. Can you use Z test? Yes, provided that it comes from the normal distribution. As long as you have greater than 30 sample sizes, then you can always use the Z test. Okay, you don't have to use the t-test. The t-test is only used whenever you have unknown sigma with small sample size. So when we talk about small sample size, N is less than 30. And also provided that the data come from a normal distribution. So in this situation, if you want to test the hypothesis using t-test, you need to have a data set, and then the standard deviation will be estimated from the sample data. So that's why in this situation, if you look through this part, okay, you can see that we have sigma over here. Okay, not sigma, but instead of sigma, we replace it with S. So this is a sample standard deviation. So this is sample standard deviation. Okay, that means you estimate the standard deviation from the given sample data, and the rest of the information will be the same. So in this case, the test statistic will be calculated based on this formula. Okay, based on this formula. Other than that, will be much the same with the previous material that we have covered before. Sama je dengan yang sebelum ni. So yang mana kita dah cover sebelum ni sama je dengan apa yang kita belajar sekarang ni. Cuma yang membezakan apa yang kita belajar sebelum ni dengan sekarang ni adalah di mana situasi kita tidak tahu nilai sigma, okay, populasi sigma tidak tahu, populasi parameter untuk standard deviation tidak diketahui atau variance tidak diketahui, dan data adalah tertabur secara normal. Dengan kata lain, kalau ini yang berlaku sekiranya sample size-nya adalah kecil, maka kita boleh gunakan t-test statistic untuk kita test kita punya hypothesis. Okay, this will give you an approximate testing procedure respective to the z-test. Okay. Alright, so how are we going to perform this test? So let's see example. Kita tengok example macam mana. Okay, suppose that we have this kind of problems. Okay, suppose that we have this kind of problem. It says here, the average cost of hotel room in New York is said to be 168 ringgit per night. Okay, $168 per night. A random sample of 25 hotels resulted in X bar, the mean average or the average price of hotels based on the sample data is $172.50 with a standard deviation of $15.40. So they ask you to test the hypothesis at alpha equal to 0.05 level of significance. So in this case, if 0.05 level of significance, this is equivalent to 95% confidence interval. Okay, and then there is an assumption here given that assume the population distribution is normal. So this is a must-have. If you don't have this information, then you cannot perform the t-test to test the hypothesis. Alright. So what is the claim here? The claim here is that the average cost of a hotel room in New York is said to be 168. So maknanya kat sini dia katakan average cost. Bila kita convert kepada symbol, it will be mu lah, the mean. Okay. That's why we have our hypothesis written as mu equal to 168. So this comes from the first statement in the questions, right? So you have mu equal to 168. Why do we use mu? Because you already know that when we talk about hypothesis testing, is always on the population parameter, not the sample statistics. Okay, the sample statistic is only being used to test the actual value of the population parameter, right? So in this case, you want to check whether H naught mu equal to 168 against the alternative hypothesis that is mu not equal to 168. Okay. How do you know that this is a two-tailed test and this is written like this? Okay. How do you know that you have to write the hypothesis something like this? Mu equal to 168, mu not equal to 168. Okay. So it comes from the question itself, because it says here the average cost of a hotel room in New York is said to be 168 per night. So dia tak katakan is said to be higher than 168. So kalau dia kata higher than 168, then it will be a one tail sebab dia ada direction. Okay, dia ada direction higher, meaning above 168. So of course there will be a direction. It will be one tail. But in this situation, there is no direction. It's said to be either is said to be equal to 168 or not equal to 168. Unless there is a statement stating that there is a direction, then you will change your hypothesis. Okay, the symbol, the operator symbol in your hypothesis, you will change that, whether is it still going to be not equal, or is it going to be less than, or is it going to be greater than. So depends on the situation given. Okay, so in this case, this is a two-tail using alpha equal to 0.05. You get the shaded region, the rejection region here to be 0.025 in probability, and you have the do not reject region in the middle. Okay, all right. So here, another information that you have from the statement is that you have alpha equal to 0.05. and then you have n is 25. So this one is less than 30. So we have less than 30 sample size and sigma is unknown. So this indicates that you can use t-test. Okay, kalau katakan you tak boleh hafal benda ni, you look at the table that I have presented and I have shared with you in my course website. So this table. So you can see that when sigma known and sigma unknown, what happened? So you have sigma known and sigma unknown, and then you have two options here. Large sample, which is n greater than or equal to 30, and small sample n less than 30. So in our situation, we have to look at the second one, whereby you have sigma unknown and n is less than 30. So the test statistic that will be used is given as t x bar minus mu naught divided by s divided by square root of n. And the null hypothesis here is given by mu equal to mu naught. And the alternative hypothesis will be mu not equal to mu naught. Kenapa kita gunakan yang last kali? Sebab tidak ada direction. And then give also the way how to get the interval, where to reject or do not reject the null hypothesis. Okay. Okay, based on this information, you know that you can use the t statistic to test your hypothesis. And in order to test your hypothesis using t statistic, of course, like the previous material that we have covered, you know that you have three ways to test your hypothesis. One is by using the critical value approach. Second is by using the p-value approach. And third is by using the confidence interval approach. So the first one is using the critical value approach. When you want to solve the hypothesis, when you want to test the hypothesis using the critical value approach, you need to find the critical value to compare with your test statistic. So the critical value will be obtained from the table of statistics, okay, the distribution table T. So in this situation, you need to know that your T can be read from the table by looking at the significant levels and also the degrees of freedom. So in this situation, your critical value is given by negative t n minus 1 divided by alpha, with the significant level of alpha over 2 over here, because it is two-tailed, so you divide it into 2. And then the degrees of freedom is simply n minus 1. So in this situation, n minus 1 will be 25 minus 1. So you have to look in the table, the value for t 0.05 divided by 2 with 24 degrees of freedom. So you will have the value over here. Of course, the table will give you only one value. Okay, one value. It won't give you two values, even though you have left and right. But you know that the t distribution have similar characteristic with the z distribution, whereby both of these distributions are symmetrical. So when we talk about symmetrical, it means that the right hand side value will be the same as the left hand side value, just that the difference will be in terms of its signs, whether one is positive and the other one is negative. Okay. So based on this information, so you have to look for t 0.025 with 24 degrees of freedom from the table. And from the table, you get the value to be plus or minus 2.0639. So you have this value minus 2.0639 and then 2.0639 on the right hand side. So in order to test your hypothesis, you have a rejection region where you will reject the null hypothesis if the value of the test statistic exceed the two values here, left and right. Okay, kalau katakan dia melebihi nilai critical value kiri dan kanan. So this is the shaded region given. Okay. Alright. So once you have identified the region, once you have identified the critical value and the rejection region with the given information, the next thing to do is to calculate your test statistic value. And the test statistic value is given by the formula below. So you have x bar minus mu divided by s divided by the square root of n. And s and x bar here is estimated or approximated or calculated from the sample data. And this has been given to you in the question. If it is not given to you in the question, so that means you have to search for the value in the output, or you have to calculate this value yourself manually. Okay, so that is the situation. In our case right now, in this example, it's already given the value of x bar and the value of s. So you just need to substitute the values into the formula. So in this case, you have x bar is 172.5 and mu is equal to 168. You take back whatever in the hypothesis. So you have 168. And then divided by 15.4, that is the standard deviation. Here you have to be very, very careful. If the given information is variance, so that means here you have to take the square root of the variance in order to get the value of s. Because you know that s is simply the square root of s squared. Okay, where s squared is the variance and s will be the standard deviation. Okay, calculating this value by substituting the correct information into the formula, you get the t statistic value to be 1.46. So you have only one values. You don't have two values because this is symmetrical, right? So what you need to do right now is to compare the statistic value with the critical value and search whether is the t-value statistic value inside the rejection region or outside of the rejection region. So in this situation, you can see that the value is 1.46. So it will be somewhere around here, right? Okay, somewhere around there. So in this case, you have 1.46. So this is in the non-rejection region. So you do not reject null hypothesis. So that is the process of hypothesis testing for one sample test with small sample size and unknown variance. Okay, unknown variance or unknown standard deviation. So based on this information, you fail to reject the null hypothesis. So you say that you do not reject the null hypothesis. So we have not sufficient evidence that the true mean cost is different from 168. So kita katakan bahawa dia ni tak benar lah. So kita tidak ada evidence yang mencukupi untuk kita support the idea that the average cost of hotel room in New York is equal to 168. Okay, so that is the situation. Alright, any questions so far? Okay, so this is how you test the hypothesis for one sample test with small sample size and sigma unknown, assuming that the population distribution is normally distributed. Okay, so in this sense, based on this example, you can say that there is not enough evidence to support the true mean cost is different from 168. So that means the true mean cost is equal to 168. Okay. Okay, that is for the a two-tailed test using the t-test statistic by comparing the t-test statistic with the uh, critical value. And of course, the critical value negative 2.0639 here can be obtained from the statistical table. Okay, from the statistical table. If you want to look at the statistical table, let me just get the statistical table for you so that we can see what is happening. Okay, so we have the statistical table at the end here. So you have you want the t-test, right? So this will be the t-test if you look through this one. So you have to look through for, in this situation, you're looking for 0.025, right? So the alpha over 2 is 0.025 for this one because this is a two-tail. So that means you have to take the significant level and divide it by 2. If this is a one-tail, so then you just use the value of alpha 0.05. But for this situation, you need to divide by 2 because it is a two-tail test. So 0.025. So go back to your table and locate 0.025. So this will be the top one, right? So you have 0.025 over here, and then find the degrees of freedom to be equal to 24. So you go down until you reach 24. So this gives you 2.064. Okay, 2.0264. Okay, 2 where is it? 2.624. Okay, 2.624. So looking back at here, you have 2.062. Ya, silap itu. 24. Oh, betul lah. 064. 064. Alright, so you get 0639. So you bundarkan yang ni ke titik permulaan, you akan dapat negative 2.064. Okay, so use whatever value that you have in your statistical table respective to the value of the alpha over 2 and also the degrees of freedom. Okay, so that is how you test the hypothesis for one sample with unknown variance, unknown population variance, or unknown population standard deviation, and small sample size, assuming that the population distribution come from a normal distribution. Okay, any questions? Okay, another way of testing the hypothesis is by using the confidence interval. You can also calculate the confidence interval based on the information that you have previously. So this is just simply taking the upper and lower limit of the confidence interval. What is the formula? So in this case, you can see that the formula is, this one is x bar. Okay, this value will be t alpha over 2 n minus 1. And this one will be 15.4 divided by square root of 25. So this is the standard error of the mean, that is s divided by the square root of n. Okay, so s is divided by the square root of n. So this one is minus and the other one is plus. Okay, so calculate this value, you get the value to be 166.14 and 178.86. So how do you read this confidence interval? Okay, you can say that since this is 95% confidence, so you can say that with 95% confidence, we are confident that the mean population or the true mean population will be between 166.14 and 178.86. So in this situation, in order to test whether you need to reject the null hypothesis or you fail to reject the null hypothesis is by comparing the hypothetical or hypothesized mean value with the confidence interval. So look at the hypothesized mean value. So the hypothesized mean value state that mu is equal to 168, right? So you have to look through 168. Is it inside the confidence interval? Yes, in this situation, you have the confidence interval from 166 until 178, right? And then 168 is somewhere here. So here you have 168. So it is in the confidence interval. So if the hypothesized mean is in the confidence interval, your conclusion is that you cannot reject the null hypothesis. So in this situation, you did not reject the null hypothesis and conclude that there is not enough evidence to say that the average is different from 168. By right, it is 168 because 168 is in the confidence interval. Okay. Okay, this is how you get the values from the t-test using a software called Minitab. So yang tak payah dapat So you boleh gunakan you punya SPSS. So saya boleh tunjukkan SPSS kemudian lah nanti kita akan tengok dalam kemudian. Okay. So kalau you dapat kat sini, so this will give you the result from the Minitab output. So Minitab output ni pun, Minitab ni adalah one of the software, statistical software similar to SPSS. This is also a commercial software where you need to pay in order to use them. Okay. Alright. So ada soalan apa-apa?